Alright, virtual learners, it's Mrs. Steppy here. I'm going to do a how-to video on how you can read, write, and represent fractions of a set, and we're even going to explore some equivalence of fractions. This is a lesson that I would start teaching in 3rd grade, but I would also do this lesson as needed in 4th or 5th grade, or whenever students need this. The set model, I try to think of the set model as things that in real life you would not cut up. So an area model would be like brownies in a pan, where you can cut up the brownies in the pan. But a set model would be things like M&Ms. If I'm sharing M&Ms with someone, or pieces of candy, I'm not going to cut up, or Starburst, I'm not going to cut up all those little things. I would do fair shares for a fraction of a set. The other model that 3rd graders need to be familiar with in Virginia, where I'm a math coach, is a measurement or linear model, which is like a number line. I do plan on doing another video on that. So that's the focus of today's video. Some tips to think about when you're doing fraction of a set. You want to pick a number of items for your whole set that can be divided into equal groups. Two of my favorite numbers are 12 and 24, just because they have so many factors. But that's not necessarily, you don't always have to do those numbers. If you want to do halving, then if you have a set of 2, 4, 6, 8, 10, 12, 14, any of those are divisible by 2. So if you're doing halves, any of those sets would work. Thirds, any of those sets would work. Multiples of 3, multiples of 4, multiples of 6 for sixths. You see that? And you can also just see where I had circled that 12 shows up in all of them. So I'm just going to be using 12 today because it's a really versatile number that I can show you a lot of different fractions of a set with. Before you start doing fractions of a set, students need to understand these words, the language of fractions, and they need to know that if I'm talking about halves, I'm talking about 2 equal parts that make a whole. For thirds, I'm talking about 3 equal parts that make a whole. Fourths is 4 equal parts that make a whole. Fifths is 5 equal parts to make a whole. Sixths is 6 equal parts to make a whole. If they don't understand what those words mean, then this is going to be difficult for them, okay? Twelfths. Let me see if I can either spell this right. Twelfths. I don't even like saying that. So twelfths would be 12 equal parts, right? So since I have 12 tabs, I can just set up my 12 tabs so I can see. And watch how many different fractions I'm going to be able to write once I have these set up for the 12. So this tab is 1/12 of the set, and this tab is 1/12 of the set. Every single one of these tabs is 1/12 of the set, because it's 1 part out of 12 equal parts that make the whole set. So then I could ask them things like, okay, well, now I want you to just show me 3/12. Show me what would 3/12 of this set look like. Well, 3/12, I would need 3 1/12, right? So here's 3/12 of the set, right? Or I could say, show me, go back to that 6/12, right? So I could say, well, 6/12 is 1, 2, 3, 4, 5, 6. Right there, 6/12. And then you can even have those conversations about, well, 6/12, what is that the same as a half? When students are ready, okay? So I'm representing by building those 12s, and then I can change up that numerator to help them understand that the numerator, the top part in that fraction, counts how many of those 12s that I have. So that's 6/12 of a set of 12. All right, so I always want to make sure that I start with defining the whole. So when I'm talking about the set model, a lot of students will not be thinking about the whole. They'll just say, okay, this is 12 things. But now I want you to show halves with these 12 things. Well, I cannot easily break these tabs in half. There's a lot of things in real life, though, that could not be easily split in half. If this was a cookie, I could easily cut a cookie in half. But if it was M&Ms or people, we would not want to cut people in half, or M&Ms in half. We would want to show fair shares, okay? So one whole set, you could say this is one whole bowl or one whole set of tabs, and I'm using 12 tabs just because I can show many different fractions with 12. So first thing I need to know is that what does halves mean? Well, halves means that I have two equal parts, right? So I'm going to split these tabs in halves. So this set would have 1/2 of my tabs, and this would have 1/2 of my tabs. So I'm going to deal these tabs out, okay? 6, yep, I got 6 in each set. So that means that half of 12 is 6, right? 1/2 and 1/2 will give me 2 halves. And remember, 2 halves is the same as 1 whole. So let's think about some fractions that I can write to represent 1/2 here. Okay, so I know 1/2 is 1 part out of 2 parts, but what else do I also know? What is 1/2 the same as? Well, 6 out of 12, right? So 1/2 is equivalent or equal to 6/12. Isn't that cool? And if I wanted to think about an equivalence for 1 whole, I could think about it as 2 halves. I could also think about it as 12/12, because if I have 12 tabs that make my whole set and I have all 12, then 12/12 is 1 whole. So just from taking 12 tabs and splitting them into 2 groups, look at all of the understanding I have just put together about half, that 2 halves make a whole, that 1/2 is equivalent to 6/12, or that 1 whole is the same as 12/12. That's a lot. Let's try a different fraction other than halves, okay? Thirds. Ooh, what does that mean? If I'm showing thirds, how many equal parts would I need to split my whole set into? Well, thirds means that 3 equal parts make the whole. I'm going to do a bar model this time, just so you guys can see a variety of ways that you could model this, okay? So say that this is 1 whole set. If I have them split into 3 parts, this would represent 1/3, this would represent 1/3, and this would represent 1/3. So if I had 1 whole, that's going to be the same as 3/3, right? Okay, so say I want to show thirds of my set. I'm going to split up my tabs into those 3 groups. Okay, so what is a third of this set? Well, I can see that 1/3 of the set is 4 tabs, right? So if I wanted to show, I've just modeled it for you, that 1/3 of the set is 4 tabs. 2/3 of the set would be 8 tabs. And 3/3 of the set, that would be your 12 tabs, your whole number of tabs. But what if I wanted to do an equivalent fraction for 1/3? Remember, each of those tabs was 1/12. How many 1/12ths make that third? 1/12 plus 1/12 plus 1/12 plus 1/12. Well, that's 4/12. So for students that are ready, you can start exploring some equivalents here. Well, you could say things like, okay, so what is equivalent to 2/3? Well, that would be 4 and 4 is 8/12. So you can see how I can start with showing those thirds and writing the fractions for the thirds, but I can also get into equivalence once students are ready. All right, let's try one more. Let's just try fourths last. I'll also show you, like, if the whole set wasn't 12, say that you were showing fourths of this set, then 1/4 would be right here, 2/4 would be here, 3/4 would be here, and 4/4 would be here. And students are pretty good at doing halves, thirds, fourths, whatever it is, when that denominator matches how many are in the set. But what I'm focusing on specifically in this video is when the denominator does not match. So I'm doing 12ths, but I'm doing fourths. So I'm grouping 12 into 4 groups. that's where students typically need a little bit more practice. So let's say I'm going to group that set, my one whole set of tabs, into fourths. I have to know what does fourths mean, right? Or maybe I don't tell them show fourths. Maybe this time I want to give them a challenge since they've been practicing. Maybe I want to say, show me 3/4. So if I'm doing 3/4, first I need to make sure that I'm dividing up my whole set. One whole set, remember, is 12 twelfths because I have 12 tabs in my set, into fourths, or 4 equal parts. So this bar model shows 4 equal parts. Each of those parts is 1/4. And I need to show 3 of the fourths. Well, let me get my tabs split up into fourths real quick. Alright, so now I've taken my whole set of 12 tabs and I've divided it into fourths, or 4 equal parts. So if I want to show 3/4 with this set, then I don't need to think about this last fourth. I just need to figure out what's in 3 of those fourths. And so when I'm showing the 3/4 here, 3/4 of my set, well, what's another way that I can do 3/4? Remember how, ooh, that's not cute. What's another way that I can think about 3/4? Remember, each of my tabs is 1/12, right? So there's 3/12 plus 3/12, that's 6/12, 7, 8, 9/12. So 3/4 is equivalent to, or the same as, 9/12. So there's another way that you can think about equivalence in fourths. If I was just showing 2/4 of the set, guess what? I only need 2 of those 1/4. So if I was only doing 2/4, how many 12ths would that be? Well, 2/4 would be 6 1/12, or 6/12, right? And then you might also have students that realize, and if not, you can help them see, well, isn't 2/4 also the same as a half? That's also equivalent, okay? So lots of different things and lots of different ways to explore the set model. We don't want to just always do what is 1/4 of 4, 3/4 of 4, or 2/3 of 3. We want to really use a larger whole set so we can really explore some of those fraction concepts with the set model, because students will be expected to do fractions of a set where the total amount in the set is greater than that denominator represented. All right, thanks so much for watching.